Hello class, we're about to start section 5.2, logarithmic functions. Complete the table of values below for the function f of x is equal to 2 to the x power and graph it on the axis. Now if we look here, if we substitute in -3 for x, it will give us these values here. Now I had to pre-fill these out because this would jump if I was writing it out in front of you. So if we substitute in -3, we would get 1/8, -2, we would get 1/4, and so on. Now to do the inverse, all we have to do is just switch out the f of x with x. So f of x is 1/8, that would become x. The x will become f the inverse of x, like we did in 5.1. Now, we have these values here. You need to fill those values in. And then when we graph, if you notice here, it does pass the, as I would say, the identity line test, but it's not called an identity line test. It's just the identity line, which is y is equal to x. And if you notice here, if we folded this graph on the identity line, these two graphs here will lay on top of each other. So that lets us know that this function and inverse function is correct. So it says the inverse of an exponential function exists. So it is a new type of function, logarithm. The inverse of an exponential function with base b is the logarithmic function with base b. So note, logarithms were first propounded by astronomer John Napier. That's 1550 to 1617. In his 1614 work, Mirifici Logarithmorum Canius Disciptio. Yeah, I really chopped all those words up. But it says here, the word logarithm comes from combining the Greek word logos, meaning ratio, and arithmos, meaning number. Napier also popularized the use of the decimal point in mathematics and arithmetic. Now we come here to the next page. Now, on this next page, we have here, it says in the above example, which is on the previous page, we listed values of the function f of x is equal to 2 to the x and its inverse. We will now write the inverse as a logarithm. F inverse of x is equal to log base 2 of x. Now, if you look here, this 2, as you see that this jump is our base. That 2 is our base. Well, let me see if I could draw a line to it. Okay. Well, we know that the 2 is the base. Now, when we come here, this 2 here is also our base. So this base here replaces this base here whenever we're writing a logarithm. So if you notice here, we have f of x is equal to 2 to the x, and we substitute in the values which we did early on. And then we will have x and then the inverse of x, which we show here. Now it says, let's write out a few statements using different notations. Now we have exponential form, which is 2 to the x, 4 to the x, 2 to the -1, 2 to the third, and 10 to the 100. These are just values that were just made up. Now, when we want to rewrite it from exponential form to logarithmic form, you notice we have our log and our bases are the same. We have base here of 2, base here of 2, and our exponent becomes this value here, which is basically called our argument. Okay, so now we have the same thing here. We have 4, so we have log base 4. And our exponent is our argument. Now, so we have log base 4 of x. So we have 2 to the -1 is equal to 1/2. So we will have, now, this is a little different. We have our base, our exponent, and we have a solution. So whenever we have a situation like this is how we would set it up. We would have our log, we will write our base, but instead of writing the exponent here, our final answer would be the argument. And our exponent is this solution here. Because if we rewrite this, this is 2 to the negative 1 power is equal to 1/2. So let's go down here again. We had 2 to the third is equal to 8. So we had log base 2 of 8 is equal to 3. Remember, when we're writing this as an equation, your exponent is always behind the equal sign. You have your base here, your exponent, and what those two are equal to when they're together written here. So 2 to the third power is 8. Now this is 10 to the 100. We have log base 10, and this is a huge number equals 100. So you could take your calculator and put 10 to the 100 power, and then whatever that number is, that is where this goes here. Okay, now, so we come down here. It says, note, to find log base 2 of x, what you are really looking for is the power that must be put on the base of 2 to give x. To find log base b of x, find the power that must be put on the base of b to get x. That means that there are always two forms that say the same thing. So we have y is equal to log base b of x, means the same thing as b to the y power is equal to x. Now, we scroll on to the next page. We're going to apply some of this that we've just learned. Now we have log base of 6 of 36. So we're asking ourselves, 6 to what power is 36? It's 2. So 6 to the second power is 36. So our answer here is 2. Now we have log 3 of 81. We ask ourselves, 3 to what power is 81? We know 3 to the fourth power is 81. Now, we come here, we have log base 5 of 1 over 25. Now, we have to ask ourselves this question. 5 to what power is 1 over 25? Okay, let's try this first. Let's imagine that this 1 was not here. Let's say this was log base 5 of 25. We know 5 to the second power is 25. But to get this 1 over it, we know we would have to take this to a negative 2 power, and that would give us 1 over 25. So this is negative 2. Now we go here to D. We have log 7 of 1/7. So now we know, if we take out this 1 here, we know 7 to the first power is 7. To make it 1/7, we know we would take it to a negative, the negative 1 power, and that would be 1/7. So our answer here would be negative 1. Now we have log 2 to the 1 over 32, and we could basically do what I just said before. We could take 2 to the fifth power, which we know is 32, and then make that 5 a negative, and we know that would give us 1 over 32. So this is a negative 5. Now we come here, we have log 9 of square root of 9. Now we want to find this answer here. Now we have to start doing things a little bit more mathematical than doing just mental math here. So let's go and show this here. We will have log base of 9, and now we need to change the square root of 9 to an exponent, which would take us 9 to the 1/2 power. Now one thing I want to stress to you is whenever your base and this number here is the same, these will simplify out, and whatever is left is your final answer. So that will give you 1/2. Okay, now we go here to G. We have log of 64 of 2. Now what we could do is this here. We could do log Well, no, we could do this. We could ask ourselves 64 to what power will give us 2. Now, in order to figure this out, we know that there are 6 2's multiplied together that will give you 64. So we know the 6th root of 64 will give us 2. But now we must change that to an exponent. It'll be 64 to the 1/6 power. And our final answer here would be 1 over 6. Now we come here to h. Now we have log 8 of 8 to the 3/7 power. Now remember what I told you all before, that if we have this base and this number is the same, that means that they can simplify out, and our exponent here, or what's left, is our answer, which would be 3/7. Now, we come here to I. We have log of 16 to the 1/4, well, log of 16 of 1/4. So let's first change this 1/4 to an exponent. So we have log 16, 1/4 we know would be 4 to the -1 power. Now, we could do this here. Now, when we do this here, we know the square root of 16 will give us 4. And we know that written as an exponent would be 16 to the 1/2 power. Okay, now, but we want our final answer to be 1/4. So in order for it to be 1/4, then this 1/2 would have to be negative. So our final answer here would be a -1/2. Now we scroll down here. It says, because we use a base 10 number system, logarithms with a base of 10 are especially important. We call these common logarithms and we don't write the base at all. So log 10 means the same thing as log base 10 of x. You see we didn't write the base, but if you don't see the base, it's assumed to be 10. And it's called the common logarithm. Now, in your course pack, you have a little extra line that I don't have here. So let me read that to you. It says, note, using log to stand for base 10 is not always the case in European countries. Upper level mathematics, science, and computer software, but will be the definition this course uses. So basically what we're saying is this here, if you were in a foreign country, this would not necessarily be the case. But since we're doing this in an American math class, we're going to use this as a common logarithm. So log of 1,000 is the same thing as saying log base 10 of 1,000. So we ask ourselves 10 to what power is 1,000? And we know that to be 3, because 10 to the 3rd power is 3. Now we have log of 1/10. So this is the same thing as saying log of 10 to the -1. And we know our base here is also 10. So these will simplify each other out. And that will leave us -1 as our final answer. Now we come here, we have log of 0.01. Now we know that this is 1 over 100. So this is log 1 over 100, which is the same thing as saying log 10 of 10 to the -2 power. Now, if you look here, we have the base. This number here is the same. So our final answer would be what's left, which is -2. Now we have log of 27. You could put this in your calculator, and we could write this as, it would actually give us 1.4313 63764, and so on.